All right, so for this one, we're also using the washer method, but we're revolving around a different axis, so it shifts it a little bit. We're going to revolve around y equals 2. So if we do that, our integral is going to be written in terms of x because our discs that are formed when I wrap around this, like from here to here, our discs are perpendicular to the x-axis. So that's the blue one right there. And then we also have the red one up there. So we got to do the bigger one minus the smaller one, but let's finish this part right here. What are our lower and upper bounds? It looks like we're going to go from -2 to +2. So we're going to -2 to +2. And then we have our area formulas that we have to write. This is step 1. This is step 2. The area formula is pi. The formula is pi r squared, but then we have to change the r so that's written in terms of x. Now there's two different solids that we're doing here. We have like the solid, and then we have the void, which is this part. So the first radius that goes from the axis of revolution all the way to the curve is going to be found by doing 7 minus 2. 7 minus 2. So 7 minus 2 is one of the radiuses, squared pi. And then the other one is the blue one. That's going to go from here to here, or from here to here. It doesn't matter which one you choose. It's still going to be the curve, the top, minus the axis of revolution. So that's going to be x squared plus 3 minus 2. Notice in both cases, the 2 is subtracting. The axis is subtracting. So we have a pi right here. We have pi r squared and pi r squared. And that blue one can be simplified, which I think I'll do right now. Instead of a 3 and a -2, we're just going to have a +1. Okay, so now I got to set them up. I got to do the volume of revolution for the outside part, and then the volume of the revolution for the inside part, and then subtract them. So we have from -2 to 2, pi is going to be on the outside. My r is 5, because 7 minus 2 is 5 squared. This is a 5. And then I subtract pi from -2 to 2, my other radius squared. My other radius is x squared plus 1 squared, and that's dx. Woo! Okay, I'm going to simplify this a little bit so I don't have to do two integrals. We have pi from -2 to 2, and I'm going to do 25 minus the other radius squared. So I have 25, which is the first radius squared, and I'm going to subtract from that x squared plus 1 squared. And I am going to have to multiply that out. So what is x squared plus 1 times x squared plus 1? That's going to be x to the 4th power plus 2x squared plus 1. And then I'm going to subtract that from 25. So let's write it out. We have pi, -2 to 2, 25 minus x to the 4th minus 2x squared minus 1. I distributed the negative at the same time as writing it. So now I have pi, -2 to 2, and we have negative x to the 4th minus 2x to the 2nd, and then plus 24 dx. Now we can finally integrate. So we get negative 1 over 5x to the 5th minus 2 over 3x to the 3rd plus 24x. And we're going to plug in 2 and then -2. Oh my goodness. That's a lot of writing. And now we got even mo. All right, so let me clear out the way here. First, we got to plug in that 2, and what we get when we plug in the 2 is -1/5 times 32 minus 2 over 3 times 8, and then 48. Next, we're going to plug into this -2 into all these x's. Make sure you hit subtract right there. And what we get is pretty much the same thing, except for because it's a -2, we get a -32, a -8, and a -48. a little bit of simplifying here. I don't like messing with negatives, and so I'm going to change this to addition and distribute the negative. Now for each term right here, like this term right here, 1/5 times negative 32, I only have to change one of those signs. And then same with this one, I only have to change one of those signs. And this one, well, there's only one number. So first one I'm going to add up is this one, just because they have a common denominator here. And you actually don't have to add them all up right now. However, I don't want to type all that. So I'm going to add up the common denominators and then see what I have to type in. So I get negative 64/5 for that one. For the next one, those ones both have a denominator of 3. I get a negative 16 and a negative 16. I add those together, I have a negative 32/3. And then I add the 48s together, I get 96. Don't forget your pi on the outside. And that's your answer. I know some of you guys are going to want to simplify that. I don't want to. And in fact, you don't have to. With calculus, you don't have to simplify expressions like that. Now, you don't want to ever leave a fraction inside of a fraction, but this would be sufficient for your answer.